In this video, we begin our discussion of the finance section by discussing what is often called the lump sum formula for investment. Okay, we can see here in this problem that there is a formula. We've talked about in class that the variable P0 is called the principal. Okay, this is the amount of money that you have to invest. This is maybe in terms of investment, the initial investment that you give to the bank. Excuse me, there is a R value. This is what's called the APR, the annual percentage rate. So it's a percentage. And for example, it might be something like 10% or 1% or something like that. 10% or 1%, right? Some percentage. N is the variable that deals with the compoundings, the number of compoundings per year. And a typical example here is 2, which would refer to something called semi-annual compounding. Okay, and if we want to then discuss how the principal P0 value grows after a time number of years, right, then one could use the formula P as a function of time is P0 times 1 plus R over N to the N times the time power T. Okay, this is the lump sum formula. Okay, and a way to visualize this picture, to this formula, is to think about time stretched out onto a timeline. Okay, let's say, for example, let's select the following values. Select the following values. Let's say that we have a P0 value of, say, $20. This is the value that we are seeing over here on sorry, let me get my presenter tools going. There are the presenter tools. Sorry about that. Okay, so you can see the $20 value here in my spreadsheet. Let's say that the interest rate R is equal to 1%, so that's a decimal 0.01, and that's what we're seeing here in this chart. Okay, let's say that we have selected the values n is equal to 2, so interest is going to be compounded twice per year. And let's say that we are going to see how this principal grows after 2 years' time. Okay, so on the picture above, we could draw a timeline for 0 years up to 2 years. Okay, and what we're seeing on this picture, what we should do is put little sub-tick marks, right? So here is 0 to 2 years, here's 1 year. And what I want to do is I want to mark out every half-year period. So here's 1/2 of a year. Here is equal to 2 1/2s of a year. Here is the value 3 1/2s of a year, or 3/2 of a year, and here is the value 2 years, which is also called 4 times 1/2 of a year. 4 times 1/2 is equal to 2. So what we are seeing here, what we can imagine is we are starting with a P0 value, right? P0 is equal to $20. And what we want to do is imagine that this formula that we're seeing here, where does it come from? It comes from by imagining the P0 value 20 growing for a half of a year to a value P1, the amount after 1/2 of a year. 1/2 of a year is 1 times a half. That P1 value is going to grow to a P2 value, where P2 is equal to the principal after 2 1/2 of a years. So the time period in this problem is half of a year. The P2 value is going to grow to a P3 value, which is the principal after 3 1/2s of a year. And finally, the P3 value will grow to a P4 value. And the P4 value is is the principal after 4 1/2 of a years. Okay, so this is the way we can visualize this finance problem, the lump sum formula, where you have a starting value, and you don't do anything else except watch this $20 value hopscotch in time and keep growing and growing money. Okay? This picture will be helpful to us when we start doing the annuity problem. Okay? So let me show you how we hopscotch across this time picture. How we hopscotch over 2 years period of time, 2 years of time, how we hopscotch in 1/2 of a year periods. Right? So we're going to make 4 hopscotches. Okay? And 4 jumps across this graph. So the way we do that, option one, is to just use our formula and go directly from the P0 value to the principal after 2 years. T is equal to 2 here. So if you want to just jump right from the beginning P0 value to the principal after 2 years time, you can do that with this formula, 20 times 1 plus 0.01 divided by 2 to the n is equal to 2 and our time value is 2. So if you would like to just use this formula, you could do so now. You could type 20 multiplied by 1 plus our R value here. You can see I've written R as a percentage our percentage as a decimal, divided by the N value, and I'm going to raise this number to the raise this to the, let me try that again, to the N value, which is in B3, times time, which is 2 years. And you can see that what we will have, according to this formula, the principal after 2 years is equal to $20.40. So not a lot, because we didn't start with a lot of money, so the amount of interest that we've earned over this time period is only $0.4 or 40 cents. Okay? There's another way to find the principal after 4 years, and that is after 2 years, or 4 time periods, 4 half-year time periods, and that's to hopscotch across this picture. And let's do that now and show how this works. There is a value I that's going to be important to us, and I is going to be the interest rate per period. That is the R divided by N value. So this is 0.01, 1% split up into 2 different interest payments semi-annually. So 0.05, apologies, 0.005, or 0.5% interest every 6 months. Okay? So let's watch how this I value helps us jump across the graph. Okay? One can say that after 1 time period, or 1/2 of a year, we are going to get the amount of money in the account is going to be the $20 we started with multiplied by 1 plus the I value. And our I value is the interest rate every period, which is 1/2 of a year. So you can see that in the first 6 months, we've earned 10 cents of interest. Now let's watch what happens as we continue to hopscotch across this picture. The 20.1 is my P1 value. That's the principal we have after 1 time period. The principal we have after 2 time periods is going to be the 20.1. We're going to hopscotch from P1 and get over to the P2 value by multiplying by 1 plus the interest rate per period. Now we have $20 and $20.2, and we're going to continue to hopscotch across here. This 20.2 is the P2 value. Now we want to take the next step, and the way we do that is by taking the amount that we had at P2 and multiplying it by 1 plus the interest rate per period, right? And there's a fast way to do this in Excel, but it's helpful to type it by hand a couple times. Go from the P3 value to the P4. So this is how much we had after 3 time periods. Multiply that by 1 plus the interest rate per period. And you can see that these values come out to be the same. Okay, so this formula that we're using here is consistent with making n jumps across in a time period of t. In this case, we've taken 2 years and we're jumping in half of a year time periods. So that's 4 total jumps to get to 2 years. And so we can see here that here is how much money we had in the account changing over time, and after 2 years we get the same as the value that the formula gave. This philosophy of figuring out how the price in the account changes every time period is going to be the essence to an annuity problem. And so ends this video on an introduction to the lump sum formula and how that is a hopscotch problem in time, and how that relates to the Excel or the Google spreadsheets for those values. In the next video, we'll look at the annuity problem, where we are making payments or regular payments or deposits into the account.